Welcome, class. The purpose of this video is to show you how to do exploratory data analysis. That's just a fancy word for descriptive statistics. It's getting into the data and finding the story that's underneath of it. There's two parts going on here. First part, there's just an art to the data analysis, and I want to demo it right off the top of the class. I'm expecting this video to be watched by my Intro to Problem Stats classes, Biostats, Statistics, Math 331, 332, various students of mine. So I'm kind of pitching it broadly. The other side of it, I just want to give a few technical pointers on R to help assure you that, yeah, this is actually doable, and just show you kind of a few things how it works. Okay, so on to the data analysis. There's a lot of places to get data. In some assignments, you may need to get your own data. On R itself, if you just type in data, then boom, there's a whole bunch of preloaded data sets on R, and they've been put there because somebody thought they were worth putting there. So those are interesting. They can be looked at. Lots of stuff. We, in particular, are going to use the famous IRIS data set. So IRIS. It's in here. So once I find it, then I'm just going to pull it out. It's in there somewhere. Hit it. Boom. There it is. It's in. Okay. Now notice it doesn't show up here in the workspace. So to get that convenience, I'm going to rename. I'll just capital IRIS equals lower IRIS. We're very case sensitive in R. Now capital IRS is a new, in this case, data frame that I've created. There it is. If I click on it, then I get the usual view, and I can see the whole thing. Very nice. Okay, so there's four features here of flowers with the species name. This is a famous classic data set. Okay, just wanted to point out one other place you can get data sets. If you go to my web page, then I've got down there several links. This data and story library is pretty good. It's got some nice curated data sets, so you can go by topic and then select. That's handy, and they're ready to get put onto R. You have to do a little bit of fiddling. Another place that you can go is Joe Hardin's page. She's a friend of mine over at Pomona College, and she's got a bunch of stuff. For example, this website here has data that's formatted for use in R. This one's got all kinds of links to many data sets, and there's just lots that you can do. So data is available, not always easy to get into R, so you have to be a little bit discerning about that. Okay, so I want to just put that out there. Now onto this iris data. There are three different species of iris that we have. So the first one is the setosa, the versicolor, and then the virginica. And there's two different types of measurement that are made. There's the petal measurements and then the sepal measurements. So the sepals are these inner parts. And we've measured lengths and then widths. Okay, so that's basically the data. This is just a Wikipedia set of pictures here. And so we put that away, and let's get into it. Now, I am going to use a file, s.ExploratoryDataAnalysis, and it would be maybe more authentic to type everything in, but it would take extra time for you, and then the record of it wouldn't be as clean as the pre-packaged one. So I'll do a slight bit of both, but you have the full record here. And just for your assurance, I want to point out functions needed. I only have 8 functions here. Histogram, box plot, bar plot, and plot. Those are the graphs. Then table, mean, standard deviation, and summary. Those are the statistics. And we'll be able to do a tremendous amount of exploration with just those 8. In addition, I've got a few optional functions that kind of expand the functionality. I think you'll see they're cool. So there we go. Okay, now I've got my name, capital Iris here, so I didn't have this written in, so I'm going to go ahead and do this. We'll do capital IRIS equals lower IRIS. Okay, now we're going to attach it. We've talked about that in class. That's the command that, let's detach it for a sec. If I want, let's say, to look at pedal.length, I just type it in, then it's not there, it's not there. So it's the attach command that actually gets it for me. And here, let's get rid of this, it's in our way. Okay, so when I do attach, that says, okay, stick it on top of your desktop. Now, when you say pedal.length, I'm just hitting my up arrow right now, up, up. Okay, 2 spots, I got it. Boom, there it is. It's accessible to me because I've attached. All right, so that's on. Now, some basic graphs, if we just want to do the histogram, hist of pedal.length, boom, I've got the histogram. That's an interesting histogram. Looks like there's something going on here with 2 groups. We can do more histograms, and I'm just going to do, oh, boom, sepal length. That one looks a little bit bell-shaped, interesting. The width of those sepals, interesting. Slight skew right, but interesting curve. Pedal length, that's the one we just did before. And pedal width, similar to pedal length. Really? I can click this arrow here on my RStudio and go back. Yeah, those are actually very similar looking. I'm looking at the scale here, 1 to 7. Here we're just 0 to 2.5. So pretty different scale, but you catch the drift. Okay, now what if I wanted all that stuff together? Well, here's an optional one. I wouldn't ask you to memorize this command or anything, but parameter allows you to adjust many graphics parameters. And if I set it to 2 by 2, that's going to give me a 2 by 2 matrix of graphs. So the next graphs that I do are going to go into my 2 by 2 matrix. And there they are. So we've got the nice titles here to differentiate, but now I can look at them that way. Okay. Now you're probably thinking at this point, yes, I've got the basic distributions. First step. We want to plunge into it a little bit deeper. Did we not say that there's a species variable, right? So I've got my 4 variables plus a species. So Setosa, it says I got 150 observations, 5 variables. Species, Setosa here, lots of Setosa. Aha, versicolor. Okay, boom. If I wanted to know how many are in each, I could do table, species, and there we go, 50, 50, 50. So that's nice. It might be nice to look at these by species then, see if there's something going on that way. So that's my next move. I'm going to go to box plots, and first box plot, ooh, that's particularly bad. So let's do undo the previous setup there, and let's rerun that box plot, and there we got it. That's pretty boring. Okay, but it is the sepal lengths. I could match it visibly with the histogram I did before. But more interesting and more to the purpose of box plots is let's break it out by group. There's some notation here, this little tilde notation. It's going to be the modeling notation we'll use all semester long. So the first position is typically your response variable. Your second one is an exploratory variable or a factor or a group or something like that. And so in this case, species is how I want to break up sepal length. And so we can see, by golly, those sepal lengths really look like they're in 3 different groups. So now we're getting somewhere. Let's check it out for the next one, sepal width. And again, I'm just clicking this button here on my RStudio. You could copy paste various things. This one says sepal. This is sepal width. Notice it doesn't show a default label or plot. I would have to pop that in, main equals, and I could put petal length. Okay, now when I run that one, then boom, it's going to say petal length. And again, I see the 3 different. And last one, the 3 different. Okay, so just reviewing those graphs, it's the second one, species width, where they're all pretty close, and the Setosa actually has the largest species width on average, whereas it had the smallest of every other measurement. So something interesting with that, that sepal width for Setosa. Okay. Let's move to comparing the relationships between these variables now. So the basic way to do that is with a scatter plot. So we can just use the plot command, and in that position, you just put whatever 2 things you want to plot against each other, X and Y. I've got sepal length and sepal width. Now, there we go. Not a lot of relationship between those 2. If you looked at the correlation between sepal length and sepal width, core, then we'd have slightly negative. This is a number between 0 and 1 that describes the strength of the linear relationship. Positive, negative gives you the slope. So there's not a lot going on there. Okay, and now I could similarly start to go through. There's the next one. Ooh, sepal length and petal length. Those do look like they have some correlation there. And again, I could go core on that. And 0.87, that's close to 1. That's a strong linear correlation, and it's positive. So that's interesting. Now, I have 4 different variables, so that would take me a while to do all the pairs, and then I would have to sort of stick them around, so there's a little work on that. And you might imagine, hey, has anybody actually come up with a quick way to do that? Of course, it's all there. So there's a command called scatterplot matrix that will do this for us, and it's in the CAR library. There are some packages this semester that we will draw their functions from. So the easy way to get it is if you go under Tools, Install Packages. Assuming you're in RStudio, then as long as you know what it is, just CAR. Here's CAR, and if I click Install here, it's going to go ahead and do it. I happen to already have it installed, so I'm not going to, but that'll work for you. And if you don't have that functionality for whatever reason, I put the command that will run it. So if you just run this command right here, then that will also do the job. Install.packages with the name of the command. Dependencies right here says, hey, if there's any other packages that it relies upon, install those as well, and CAR has several. Once I do that, let's go ahead and turn on the library. Boom. It loaded 2 required packages. And then I'm going to run scatterplot matrix. Let's see what it does. Okay. Now I've already used some of the arguments, and because this is an optional command, I'm not going to go into detail about them. But you can see that, wow, this thing's got a lot going on. It's shown me all the scatter plots, and it's got histograms. We've seen those before, with little lines going through to tell me sort of what a linear trend would look like. As I'm looking through here, I'm seeing, wow, there are several places. Petal length, petal width. This one is petal width on the y-axis. This one's petal width on the x-axis. So these 2 are just flipped with the axes. So you only need to look at 1/2 of the graphs, not both. Okay. I keep seeing this break in groups that matched up with this bimodal histogram that I had before. And so I bet you're probably thinking what that is. I wonder what characterizes that group there. Is it a whole species? Well, we can get at that using color. And I'm not going to go into the detail about color, but well, let's try this. Did I run it? Okay. Wow. Huh. This was the default colors, and to me, it's just kind of ugly with this black and stuff. So this next line, I went ahead and just fixed my own colors. Colors are numbered by numbers. They can also be typed in by name. So I just did colors 2, 3, and 4 instead of 1, 2, 3, which was defaulted on the previous line. Now into our exploration. Sure enough, look at that. Red, which turns out to match with setosa. The setosas are all grouped together here with the petal lengths and widths. And then the green, the versicolors, and the virginicas are pretty well separated, but there's a little bit of overlap. So good, we found something there. And similarly, you'll see those setosas are separated out in most of the other graphs. Aha! So we're starting to penetrate the structure here and find out what's going on underneath. Now, let's see. I want to go ahead and introduce you to another approach here, and we'll just pop it out. Library RGL, if you run it, again, you'll have to install the RGL package. Okay, so we could go and Tools, Install Package, type in RGL right here. And sure enough, there it is. Okay, now to run it. Okay, it didn't show here because this package brings in its own separate window, but it's a 3D scatter plot. Aha! Now this is setosa right here. So that's interesting. Why did I pick setosa? I don't know. I do want to make one observation that it's okay. 1 through 50. The structure here is different. 1 through 50 means rows 1 through 50, which thus it's only setosa, and then columns 1 through 3. So it's actually plotting sepal length, sepal width, and petal length. Okay, so if you notice, sepal length, sepal width, petal length, those are the 3 axes plotted. Now, if you want to go something else, then I could do, let's see here, the next group, which is versicolor, and then this, so let's look at it. Oh, hey, now we've got the 2 groups. And lastly, we'll do virginica. Now I have a 3D scatter plot of the those 3 particular variables. Now I could switch out and make a new 3D scatter plot of another combination of the 3. But again, this allows me to kind of dig in and look at the data. Okay, so that's a nice tool in your toolbox if you ever wanted to go 3D level. What about a basic bar plot? Let's look at species. Well, I showed you table before, so we just hit that one. There's the table, and it's giving me, let's rerun that because it didn't show everything in one row. There we go, table. And bar plot does not work on the data itself, but a bar plot needs the data to be already grouped in its bins, unlike a histogram, which does all the work for you. So you use the table command in conjunction with the bar plot to get it. This is a completely boring and irrelevant plot, but at least it shows you the functionality. Okay, now let's move into the statistics, and we're nearing conclusion here. If I want to just do basic statistics, then the commands are simple. I've introduced them to you probably at this point. Mean, sepal length. Okay, no problem. SD is standard deviation. Boom, I got a standard deviation. And there's a nice command called summary. If you hit that, then boom, you get this summary. And what I would be interested in doing is looking at the histogram of sepal length and comparing these statistics with my histogram. Okay, so the mean is 5.8, the median is 5.8. That's telling me mean equals mode. I probably have a symmetric distribution. As I go in here, 5.8 is looking about right here. So indeed, yeah, that's right in the middle of a roughly symmetric distribution. So I'm reading that well. If the mean was larger than the median, then I would have extra data on the high side, giving me a skew right distribution. Okay, let's see, the max is 7.9, so up here. Min is 4.3 over here. And the standard deviation is 0.8. So remember, about 3 standard deviations on both sides of the mean should be almost all the data. So 5, roughly 2.5, let's say. 5.8 plus 2.5. Yeah, that should pull me up there. Looks about right. So that's a relationship between this center, this spread, and the shape of my distribution. So that's important. Now, again, it didn't penetrate to just the setosa, let's say. So I'm going to up arrow a couple spots, sepal length. Well, what if I only want setosa? I could go ahead and do rows 1 through 50, and that would give me the mean sepal length there. And then I could also histogram that. So I pop up arrow, I go home, delete, 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 hist, boom. That's histogram of sepal length 1 through 50, which is setosa. So I got that, and its mean is 5. So 5 is right in the middle there. So again, we could go through and compare the statistics with the graph so we can make those connections. That's good. Okay, I wanted to show you one other piece of syntax here. In place of 1 through 50, what if the data is all disordered and it's not in a nice clean 1 through 50? You can also do species. I only want species where it's equal to setosa. Do I need 2 equal signs? Yes. Why? It's a logical command as opposed to a mathematical one. And so let's just run it and show you what happens. Boom. Ew. Wrong button. Okay, I lost it. Okay. So we had sepal, no, species, equals setosa. Okay, and you'll notice same exact graph as the previous, but called it on a different way. I do that in various places of this document that you can look at. Now, what I did run earlier was the library mosaic command. You don't have to have this, but it makes the mean do a very nice feature. Namely, I can call mean with the linear model argument, and it gives me the mean of sepal length by species. And so now I get that setosa mean that I had before, along with versicolor and virginica, using the same syntax as the box plot and in future commands that we'll learn. Again, it works with standard deviation and so on, and we need the mosaic package for that to work. Okay, now once you work through and you kind of dig in a little bit and you get some commands typed out, a lot of times you're like, wow, I don't want to run through that again for another variable. And so I can copy this and then paste it down, and then I can change these by hand and run them. Okay, and then boom, I've got it by sepal width instead of sepal length as I had before. But even that can get a little bit dull. So I want to show you another speed up here. I've got sepal width. This one's petal length. Let's go down here to petal width. Let's just suppose that I take this copy and I didn't have petal width. Let's delete. I'm going to paste in, but I want petal width. So what I can do is I'm just going to put my cursor here, and I'm going to go into Edit, and I hit Find, and you've got a little window here that you can find anything you want inside of a big long file, which is useful. Some of mine are a little bit long, but you can also replace. So I wanted to replace sepal width by petal width. So let's go sepal and then replace with petal. I never almost would use a replace all, but I like to go one at a time. Boom, petal, 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 and voila, we're done. So now I just go back and I've got petal width in place of sepal width. And you can check this out, run the thing, boom. Now I got the stats for petal width, and we're good to go. Okay, so I've kind of demoed relationships, I've demoed those things. Let's see what's left. I got correlations in here. Correlations we've looked at a little bit, so I'll leave that to you. So just trying to summarize things together, we've looked at a variety of plots, and we've got a record of them here, to try to penetrate what's going on inside the data. And we discovered that there really was a genuine difference in these different species, and we came at it from some different approaches. The bimodal distribution in the histogram, and then also these scatter plots really keyed us off to that. And once we found that, we were able to go in and characterize them, although we didn't state it all, by looking at the specific statistics. And that would flesh it out. And we were even able to quantify those associations a little bit with our correlations. And all that was done in a relatively short amount of time. Using these tools, you can just start to plunge in and discover the story behind any such data set that you might encounter. So I hope this is an interesting and useful opening to it for you. And Lord bless you. Look forward to seeing you in class.